We have seen this pair of cavities before, a pass notch on the bottom, a bandpass filter on the top with two connections here, and the bottom one just has a T connector. This is the response, which is down quite a little bit at 140 and 150. This is the peak at 144,600, which could be a transmit frequency or a receive frequency, depending on the desired combination of inputs and outputs. This would be the output frequency of the transmitter being attenuated at the receive input frequency. For example, if the receiver was down, was at this frequency, and this would be the output of the transmitter. So it's 28 dB down at 144,600, and it is minus 1.5 dB down at 145,100. A fairly typical situation with a bandpass filter and a pass notch filter together. So let's look at the match that this particular combination has. So if we take this device, which is a ZFDC-20-5, we take the output of the tracking generator and put it on this port. And we take the input to the spectrum analyzer and put it on the coupling port. If there's nothing on this port, this is open, we can go tracking generator, normalize, turn it off, turn it back on, and it will put it right back up at 0 like we had before when we were looking at the pass. So now we're calibrated again for looking at the return loss. So if I was to take this little puppy off, just for grins, we'll put the load on here. This is a 50 ohm load, and it gives us 27, almost 28 dB. So 28 dB of return loss is good in anybody's book, and it's about in the capability of this particular product from Mini Circuits. You'll notice the writing on here, Mini Circuits, somewhere along the line somebody got cost reduction happy, and these labels are really crappy these days. They rub off, and so that's why you have a felt tip pin on here, not just so it's visible, because it wasn't visible at all. All right, let's look at our second load here, which is 75 ohms. That, according to the charts, should give me about 14 dB return loss. And lo and behold, it does, 14.5, so that's close enough. So looks like we're in calibration, and can use this for looking at return loss from 140 to 150. As you see, a 10 megahertz spread around 145 megahertz center frequency, so plus 5, minus 5. All right, so now we can put this back on, and we'll put it on this unit here and see what our return loss is. Well, that doesn't look very good, but that's because we don't have a load on the port. So I just put the load on the port here, and now I have a 50 ohm load for this entire package. You'll notice that 145/100 is minus 26 dB return loss, which is a good match in anybody's book, and that the notch, of course, will be a very poor return loss, which is marker number 2 here, only minus 1.5, 1.6 dB, but it's where the notch is, so of course it's not matched. So that shows the opposite curve of what we saw before, where we have a good return loss situation here and a poor one here, and that's what we would expect. So that's how you would deal with trying to check the tuning on these guys. You adjust the screws here, the rods according to what you need to, and possibly even adjust the notch slightly until you get a good overall picture of what you need. And then we can go again back like this and put this on the input here of the combination, put this on the output in place of the load that I had. And it's off the screen because we haven't normalized it. So let's normalize it for this situation. So we'll put the bullet in here and tracking generator, normalize, normalize off, normalize back on. There we are, back at our 0 reference. Put this on the output. Put this on the input. And there's our pass curve again. Minus 28 again. Marker 1 minus 1.56. These are compact cavities that I picked up from where I work at Telewave, and these particular ones are sort of old and beat up, so we might be able to improve that performance with these units if they were not so beat up. But that's approximately where you'd be in this particular configuration. And another pass reject cavity would get you about 70 dB of isolation here, more than likely, which is what you'd need for a typical duplexer on each channel. So you'd have 3 cavities on each with the passband filter here.